working on today are unit vectors and some ideas with vector operations. Here are just some general ideas of what we can do. To find the length of any vector, we just take, for example, u, we'll take the x component, square it, y component, square it, take the square root. This is formula again. When you're adding two vectors together, we add each component individually. So the two x parts of the vector and that component, and then the two y components, that's how they add up. Same with subtraction the same way, and then we can do scalar multiplication. So if we take a vector, multiply it by some number, we multiply each individual component by it. So to see what that looks like when we actually do some sample problems, find the length of x, we're just going to do each individual component squared, add them up, put it under a square root, and that's how you find your length, just like that. Now when we do x plus y, all we're going to do, add the initial components, so the first components in each, and then add the second components in each, 3 plus 1. Then that means that the vector will be 2, 4 in the vector. Same with subtraction, except we're going to subtract this time. And then over here we'll have 3 minus 1, so we should get, in this case, 6, 2. And then this last one, all we'll do is multiply each component in x by 3. So 3 times 4, and then 3 times 3 means that I will get 12, 9. So that's just some basic ideas. We'll go more in detail with that as we go forward. But the other part that's real big right now is the idea of a unit vector. A unit vector is just a vector that has a magnitude of 1, and we do it by, or we find what the unit vector is by taking a vector and then dividing it by the length of that vector. So the way we'll do that here is, say we have a vector, negative 2, 5, and we need to find the unit vector for it. So first thing we need to do, find its length, which we just said we'll take the square root of each, or the square root of each component squared. That'll give me the square root of 29. So then I want to do the vector divided by its length. So that means I'm going to take each component in that vector and divide it by the square root of 29, divided by that length. 5 over square root of 29. That right there is your unit vector as it is. Now I would suggest trying to simplify it. So negative 2 square roots of 29 over 29 and 5 root 29 over 29. I would suggest doing it like that, but that's what you want to look for. This is your answer right here for your unit vector. Alright, let's put it all together now with one final problem here to go start from scratch, to go from an endpoint, or from an initial point to an endpoint, find the component vector first, then find its length, and then turn it into a unit vector. Pause the video right now, see if you can do that, and when you come back, you'll have the answers waiting for you. Alright, let's do that again. Component vector, you should have done for negative 4, 4, because you should have done negative 1 minus 3 for the x component, 0 minus a negative 4 for the y component. That's how you got those. When you found the length, you should have gotten the length of the square root of 32, which should simplify to be 4 square roots of 2. And then, when you do your unit vector at the end, you're just dividing each term there by 4 square roots of 2. So this is what it should look like. Now you have 4 in the numerator and denominator, so those should cancel out. And that should leave you with something that looks like this. Oh, let's try that again. A few crazy things happening here. So you should get, right here, you should get negative 1 over the square root of 2, positive 1 over the square root of 2, which, again, will simplify negative root 2 over 2, and positive root 2 over 2. That's what your vector will look like. That's your unit vector in